describe and predict natural events in the physical world. So right here is an example of how space works. Right here is an example of what happened when we collided two, I think it was photons to create a Higgs boson, which is a particle that gives stuff mass. And right here is the Calibri-Yau manifold, which is a model of how 11-dimensional space-time would work. No. Oh.
Magic.
It's science. Who are some notable theoretical physicists? Many people, when they think of theoretical physicists, they usually think of people like Albert Einstein or Stephen Hawking, but
Patrick.
Patrick.
Use this instead of your finger.
Okay.
Yeah,
Some lesser-known physicists include Georges Lemaitre, who proposed the Big Bang Theory, and Max Born, who is a pioneer of quantum theory. And then basically, one good thing if you think outside of the box, you'd be a good theoretical physicist.
Hey, Mr. Morrison, I got a question for you, sir.
Yes?
What is theoretical physics?
Okay.
I am not very good at science.
Theoretical physics is a branch of physics that employs mathematics and thought experiments in an attempt to explain and predict events in the natural world.
Ah, so
Basically, if you can predict it, it could possibly happen.
I like it. Okay, thank you, sir.
Gentle, Patrick.
Alright. How do you become a theoretical physicist? First, you will need a PhD and a postgraduate study. Second, you will need a degree in theoretical physics. Then, you will need to be very skilled at mathematics and have the ability and talent to create and understand abstractions and complex concepts, or otherwise known as thinking outside the box. Lastly, if you are hired, you will be paid approximately $109,600 per year.
Sweet.
Chose the wrong profession.
What are some notable ideas / discoveries by theoretical physicists? First, there is the Higgs boson, proposed in 1964 and discovered in 2012. It was proposed by the physicist Peter Higgs, and it was a theoretical particle that gave objects mass, but it's no longer theoretical because we found it. Then there is relativity, proposed by Albert Einstein, that says basically think of space as a blanket or like a trampoline, and placing a huge bowling ball in the trampoline would curve it. That's how space works. Then there's the Big Bang, proposed in 1927 by Georges Lemaitre, a Belgian priest. Because at the time, people thought there was only one galaxy in the universe. It was called island universe theory. But after Edwin Hubble discovered the universe was expanding and there were more galaxies, he figured that if you rewind time, it all comes from a single place. And in 1964, when using a huge radio telescope, they discovered static wherever you would point it, and we discovered that was basically the sound left over from the Big Bang. Then here's another one by Albert Einstein: gravitational waves. He first proposed them in 1916. And imagine like taking a rock and throwing it on a pond, and it creates the ripples in the pond. That's kind of like how two objects work in space works. And you see, 3 billion years ago, two black holes collided and created these waves, and it wasn't until 2015 that we actually discovered them. And then finally is Schrodinger's cat, and here's a little experiment. And it's basically a thought experiment revolving around quantum mechanics, that there is no certainty for particles in the universe. And right here is a prediction of where an electron could be at any time, but since the probability never reaches zero, theoretically, you could have an electron of an atom on the other side of the universe.
Excuse me, Patrick?
Mm-hmm.
Could you explain for us Schrodinger's box with the cat, like what actually happens?
Okay, basically imagine you have a box and there's a cat in there with poison. And there's a hammer that will break the poison, but you are never able to find out if it's alive or dead until you open the box. This is a thought experiment relating to how quantum mechanics states there is no certainty or causality in the universe. How a particle could be theoretically at two places at once, or not even exist at all. That's what basically it means.
So the cat could be both alive or dead, and we wouldn't know unless we open the box.
And the idea in theoretical, or in quantum mechanics is that we don't know if a particle exists until we detect it. We look at it. Or the information might change once we look at it. Now, some may be frustrated by the fact this field doesn't much require physical observation, but more mathematics. Now, this is because basically mathematics is basically a universal language that if aliens were to send us a signal, they would use mathematics, not English. Without this field, the theory of relativity, the Big Bang, these ideas wouldn't have ever gone mainstream, let alone existed at all. And they have revolutionized our understanding of the universe. Because without them and their mathematics, how could we know if a light beam and could be both a wave and a particle? Couldn't. Now, what's shown right here is like how waves work, particle waves. And over here is an example of time dilation. Basically, if you were to ride on a spaceship like 25 or 50% of the speed of light, you would stay around the same age, but when you return to Earth, everybody you know would be much older. That's how that works. Now this is what I like to call it the smartest photograph ever taken, because it includes some of the smartest men in history. Here in the middle is Albert Einstein. Here is the aforementioned Erwin Schrödinger. I think this guy's Max Planck, but I'm not sure. And I think this guy is Max Born. I'm not sure. I think I saw Niels Bohr in there. Oh yeah, here is one. Werner Heisenberg, yeah. And here is a visual reference to the universe on how it started out as an initial singularity, but for the first time it expanded rapidly. So when it expanded rapidly, at first particles couldn't form, quarks couldn't form to make protons, neutrons, basic building blocks of atoms. But eventually, as the universe cooled, it was able to. Now, this is what the universe looks like now. It looks like spider webs, kind of. And there are superclusters, and in those superclusters, there are clusters, and in those clusters, there are galaxies, and with those galaxies, there are planets and stars, and possibly even life. Now, why theoretical physics? Some may wonder, why do we study the universe? What is there to discover? The answer is a lot. Humanity as a species has always looked up and wondered what is out there and who are we. Well, for millennia, the only thing that could really explain this to the masses was religion, until the advent of astronomy and later modern cosmology. Early modern astronomers believed the universe, as aforementioned, static and eternal, and that the Milky Way galaxy, ours, was the only galaxy. We live in an island universe. But as discussed earlier, we know George Lemaitre would propose the idea of a primeval atom due to discoveries that the universe was indeed expanding. He was both a priest and a skilled mathematician who believed personally that God had created the Big Bang and set in motion evolution. He, a theoretical physicist and cosmologist, discovered a new cosmic truth. So, if we know all this, why do we continue to look for this new stuff? Don't we know everything there is to know? Well, the answer is no, we're far from it, and that there are plenty of things to discover. Like if relativity and quantum mechanics can be unified, since they are both valid theories, they're incompatible. And if string theory is correct, or just an advanced thought experiment. And right here I showed the Greek letter lambda, which Einstein used for his cosmological constant, because back then people thought the universe was static and eternal. Finally, or I think this might be finally, but I'm not sure, wormholes. In science fiction, you almost always see interstellar spaceships use wormholes. But these fantastical transporters are a thing. Albert Einstein and Nathan Rosen came up with an equation and concept called an Einstein-Rosen bridge in 1935. And basically, if you bend space itself, you can travel to any place faster than the speed of light. However, no scientist has ever discovered one. And here's a little video that goes more in depth, but I'm not going to. And then finally, I think this is the future of the field. We have already discovered many things using theoretical physics that were only a hypothesis, but now we have found much more evidence to support the claims. From the Higgs boson, there's the Higgs boson, a particle that gives everything in the universe mass, which was discovered in 2012. And the Large Hadron Collider on the Swiss French border is constantly looking for things like the elusive graviton particles that emit gravity. Many scientists, such as Stephen Hawking and Ludice, I'm not sure how you pronounce that, believe this is the most exciting time to be a theoretical physicist because of all the advanced technology we have. Now here is the aforementioned Deanne, I think that's how you pronounce it, and here's Stephen Hawking with Pope Francis, part of the Pontifical Academy of Sciences, I think. And here are my sources, and the end.
Good job, Patrick.